Math 6 students, today we are talking about volume chapter 8 section 4, volume, I'm not talking about how loud something is, of rectangular prisms. All right, the essential question, how do I find the number of cubes? Number of cubes? We've only talked about number of squares it takes to completely fill a prism. Cubes it takes to fill a prism. Okay, you might remember that area is squarea, and squares are flat, but cubes are not flat. Cubes are in three-dimensional space. They have length, width, and height. Whereas squares just have length and width. So to understand this, well, first we'll go through the key idea. Volume of a rectangular prism. The volume V of a rectangular prism is the product of the area of the base. Area? I thought we were talking about volume. And the height of the prism. I should have a rectangular prism also highlighted here. Area. Why would area, which is squarea, have anything to do with volume, which is the number of cubes? Let's take a look at this picture we have here. Imagine that the top of this thing was our base, right here, the top. And it can be a base, of course, because in a prism, any face that has a parallel and identical face, there's a parallel and identical rectangle on the bottom of this thing, or congruent, right? Identical means congruent. Then it's a base. So let's say this is the base. Do you see how if I found the area, of this thing, I would also be finding the number of cubes there would be in this top layer. So if I did the length, which is 1, 2, 3, 4, right? 4 times 3, that would be 12 squares. That would also be 12 cubes on this top layer. And if I know how many cubes there are on the top layer, I can then multiply by how many layers there are. In this case, there are 5 layers, as you can see. And then I could figure out how many cubes there are in the entire rectangular prism. That is volume. So the way they have it here is find the area of the base, and I guess they're also making the top the base. So the area of the base, and notice it's capital B. That B stands for area of the base, and then multiply by the height, which is the same as the number of layers of cubes that there are, in order to find the number of cubes to fill the entire prism. Now, if it's a rectangular prism, what is the formula to find the area of the base? What is that formula? It's length times width. So notice from this first formula that has the capital B, which stands for area of the base, they got to this formula where they replaced the capital B, substituted with length times width. All right, let's take a look at an example, and you're going to totally get this because I just know that you will. Question: how can I find the volume of a rectangular prism with fractional edge lengths? Fractions. I'm scared. Tengo miedo. Find the volume of each prism. Well, there's only one here, so I guess we'll find the volume of this one. Okay, so what did we just go over? The volume of every prism, really, but we'll say just a rectangular prism here right now. Sorry, my pen's not working. There we go. The volume of this prism is going to be V equals capital B times H. Now, we would not be using this formula if it asked to find surface area, but it's finding volume, so this is the formula for that. Okay, so how do we do this? Well, we're going to find the area of the base. Let's say that the base this time is this bottom rectangle. Can I say that that bottom rectangle is the base? Sure, because it has an identical or congruent parallel rectangle at the top. Let's say this is the base. Well, capital B stands for the area of the base. So I like putting my line, so I have a left and right side, and then I'm going to substitute in to that area of the base the formula finding the area of a rectangle. What is the formula finding the area of a rectangle? We can use base times height, but in this case, we already have this height that we're going to have to need later. which is how far it is between these bases. So how about we use length times width, the old length times width. So I have substituted length times width in for that capital B, and then the H is just chilling out here. It's just waiting. So if I find the area of the base, that'll be the number of squares it takes to cover this base. So I substitute in for length. I'm going to use parentheses for all this. There's going to be my length, there's going to be my width, and this one's going to be my height. Okay. Length, let's say that's 7/8 of a meter. Width, let's say that's 1/2 of a meter. And height, okay, this is the height. It's the perpendicular distance between the bottom base and the top base. So this top and the bottom of the bases, the distance between them. In other words, it's how many layers there are. And there's 5/5 meters. Okay, so now we have this big, huge, long fraction multiplication thing going on. So I'm going to do this in two ways. The first way is the advanced way. Well, actually, never mind, we can't do that. So we'll do it just the regular way. 7/8 times 1/2 times 5/8. How do I multiply fractions? I multiply numerator times, don't say denominator, times numerator. 7 times 1 is 7, times 5 is 35. 8 times 2 is 16, times 8. Oof, I don't know what that is, but maybe I can multiply in a different order using community property. What's 8 times 8? That's 64. 64 times 2, I know what that is. It's 128. Now, what does this fraction mean? Meters squared? We're not finding the number of squares. It's not going to be meters to the second power. It's meters times meters times meters. That means that you have 3 factors of m being multiplied. So it's meters cubed. And of course it's meters cubed because we're finding the volume, and volume is cubes, not squares. So first we write the volume for, or we write the formula for the volume of a prism, which is always V equals capital B H. Substitute the formula to find the area of the base polygon. So if this was a triangle on the base, then we would have wanted to do length times width divided by 2. But since it's a rectangle, I'm just going to do length times width. Substitute values in for length, width, and height. Right. You're in 3D space, so the units will be cubed. Okay, so we know that it takes 35/128 of a meter cubed to fill this thing up. Does it make sense? Is this even a whole meter cubed? No, it's less than one. It's a fraction of a meter cubed. But doesn't that make sense? Look at these dimensions. None of the length or width or height are even 1 meter. So this should be very small. A whole meter cube shouldn't fit inside of this thing. That's why this makes sense. And that's what we always do. We try to do our writing brain. That's when we're writing out formulas, substituting in. And then our thinking brain is what we got, the volume. Does this make sense? And hopefully it does. All right, I'm going to pause this video or stop this video, and then I'm going to do the second video. So I will be right back.